We are going to do problem number 19 for factoring sums and differences of cubes. But before we get there, I want to do a quick reminder of how to multiply, raise exponents to another power. So if we have 7x quantity squared, I've got all that squared, I have to think about the rule that says I take the outside power here and multiply it to the inside powers. Well, it doesn't look like I have inside powers, but that's because there are invisible ones on these guys. So my rule says, okay, multiply the 2 to both of those, and I end up with 7 squared and x squared. And of course, 7 squared, that just means 7 times 7, so that's 49, and then the x squared. I can do the same thing down here. Have an invisible 1 there, and then I've got a 2 on my x, power 2 on my x, and the 3 is going to multiply in to each of those. So we end up with 4 cubed and x to the 6th, because 3 times 2 is 6. 4 cubed is 64, got that memorized, and then x to the 6th. Alright, so to our problem, number 19 is 343 m cubed plus 64 n cubed. Now this is a sum because I've got a plus sign in the middle there, and I know that I have to have just 2 terms for it to be a sum or a difference. It has to be only 2 terms, and I have to have perfect cubes of things for me to be able to use this pattern of sums and differences of cubes. So I'm looking at 343, the coefficient on the first term, and I'm thinking, okay, it's kind of a large number. I'm not really sure what times itself 3 times gets me that. I could use my calculator, or I could use some things that I've got memorized and do some guess and check to get there. But due to time, I will just tell you instead of telling you how to get there. So this would be 7 cubed. And then I've got the m cubed. I know that part. And then I've got a 64. That's 4 cubed. That one's a little easier to remember. And an n cubed. So I could write my first term as the quantity of 7m all cubed. I've got 3 copies of 7m. And I can write my second term as a 4n quantity cubed, because we just went over that if I've got something raised to a cube like that, then the powers are found by multiplying the outside exponent to the inside ones. Well, if I do that, I get 7 cubed and m cubed, because they each have a power 1. But I need it to be written as a quantity square or quantity cubed like this, so that I can follow the pattern. I can fit the pattern of the cube. So then, my rule says I'm going to end up with a binomial and a trinomial. And I know what the sign is by looking at the sign that I start with. That comes down and appears inside the same, inside my binomial the same. And then I know the next sign, the first one in my trinomial, by doing the opposite. So I add plus, and I'm going to do minus. And then I always end with a plus, no matter if I've got a sum or a difference to begin with. And I'm going to use a bunch of different colors so that you can see where things are going. It takes a little bit longer to have to switch pens. But my 7m, my first guy, my first term becomes my first term in the binomial. So the inside stuff shows up there. And then the inside of my second term, which is the 4n, he shows up as the second term in the binomial. And then I find the next term, the first one in my trinomial, by squaring whatever I put in the first spot. And I do the same thing with the 4n. He goes in the last area of the trinomial, and I square him as well. And then to find the middle, I actually multiply my 7m and my 4n, whatever two terms are in the binomial get multiplied together. So I've got 7m times 4n goes in there. And then I need to clean it up, and so we'll squeeze it on the next line here. We've got 7m plus 4n. That looks pretty clean. But this needs a lot better. So 7 squared is 49, because that power 2 is going to come in and hit the 7. It's going to come in and give me an m squared. Then I've got minus 7 and a 4. 7 times 4 gives me 28. And then I have an m and an n. So since they're different, I just write them next to each other. Can't combine them. And then my 4 squared gives me 16. And then I've got an n that gets squared as well.